work, energy, and power. This lesson 4, we will discuss 5.1, work. 5.1 work, the learning outcomes. First is define and apply work done by a constant force. Second, apply work done by a constant force and from a force displacement graph. Work. What is work? Work done by a constant force is defined as the product of the component of the force parallel to the displacement. So let's say you have box that is pushed forward. So this is the displacement. Then force that is parallel to the displacement and the displacement of a body. Or work is defined as the scalar dot product between force and displacement of a body. So the equation of work is W equals to force dot displacement F dot S, where when you have a dot product, dot will be transferred into a cos product. So you will have F cos theta times with S, which is also equals to Fs cos theta, where this theta is the angle between your force and your displacement. So F is the magnitude of force, S is the displacement of the body, then the theta is the angle between force and displacement. Work is a scalar quantity. What does it mean by scalar quantity? Scalar means it has magnitude but no direction. So it only has magnitude, no direction. The SI unit for work is kg m squared s negative 2, kg m squared s negative 2, or work is the same unit as energy where we use joule. Joule is defined as the work done by a force of 1 Newton, which results in a displacement of 1 meter. So 1 joule, force 1 Newton, and the displacement of 1 meter in the direction of force. 1 joule equals to 1 Newton meter equals to 1 kg m squared s negative 2. Applications of works equation. Case 1. Work done by a horizontal force F on an object as shown in figure 1. So you have a horizontal force, then this is the displacement of the object. So based on the equation, W equals to Fs cos theta. What is the theta here? So when you have your force is parallel, your force parallel with your S, so your theta angle between F and S is equals to 0 degree. So what is cos 0? Cos 0 is maximum, which is equals to 1. So here, from W equals to Fs cos theta, so your cos theta will give you 1. Now, the equation of your work done will be Fs. So this is the maximum work done when you have your force parallel to your S. Second case, work done by a vertical force. So you have a vertical force and an object, but the displacement of the force is to the right. So you have force upward, the displacement to the right. Based on the equation of W equals to Fs cos theta, now let's look at what is the theta. Force and S. So over here, you can see that the theta is equals to 90 degree. What happened to cos 90 degree? Cos 90 degree is equals to 0. So here, your cos 90 is equals to 0 Fs times 0, which will give you your work done equals to 0. So this means there is no work done when you have your force perpendicular with your displacement. Your force is perpendicular with your displacement. Case 3. Work done by a horizontal forces F1 and F2 on an object or work done to move the object. So example, you have two person push a box. Okay, you have two person push a box. So basically, the first person will exert force 1. The second person will exert force 2 to the box, to the object. So now you have force 1, force 2 to the right, and the displacement of the object is also to the right. How to calculate the work done for the whole system? So let's look at separately. Work done from first person. W1 is equals to force from person 1, F1, times S cos 0. Remember, the formula for work done is Fs cos theta. Now, because you have your force parallel to the displacement, so your work 1 will give you F1 S cos 0. Work 2 is equals to force from second person, F2 S cos 0. To calculate the total work done, you have to add up these two. The work from person 1 plus work from person 2. So W1 plus W2 is equals to F1S plus F2S. Where does this cos 0 goes? Cos 0 is equals to 1, which will only give you F1S plus F2S. Or you can write your work done, the total work done is equals to, now the displacement for force 1 and force 2 is the same. So you can factorize your force 1 plus force 2 times with S. So the F net is equals to your force 1 plus with your force 2. So you just have to plus these two forces, which will give you your F net. The total work equals to work net, which is comes from F net times S. Case 4. Work done by a force and frictional force on an object, or work done to move an object, where now your force, you have an angle. So you have angle to the force. When you have more than one force, so you have to calculate the total work done. Work net is equal to F net times with S. How do you calculate your net force? From this figure here, let's look at when we resolve it into X and Y component. So from here, your X and Y axis, okay, X and Y axis. So first, you have your force at an angle of theta. Then you have your friction to the left. So friction to the left. So this force at an angle, you have to resolve into your x component, where your fx equals to f cos theta. Then this is your fy, which is equals to f sine theta. Okay. How do you calculate your F net? Now remember, to calculate work, we have to see the force that is parallel to your displacement. Force that is parallel to your displacement. So when you have your S to the right, you have to look at the force that is parallel to your displacement. Your displacement is to the right. So from here, as you can see, to calculate your net force, you will have your F cos theta, from here, minus your friction. F cos theta minus friction, which is equals to MA. This comes from the formula of F equals to MA. So your work net, F net as, what is your F net? F net is F cos theta minus F. Just substitute into your equation. So you will have F cos theta minus F times with S, or F cos theta minus F is equals to your MA. So you just substitute your F net, which is your MA times with S. Caution, work done on an object is 0 when either F is 0, remember, W equals to F S cos theta. So you have three variables: force, displacement, and angle. So your work done can be 0 either when you have F equals to 0, or your displacement equals to 0, or your theta equals to 90, which will give you your cos theta equals to 0. So example, force 0, when you have a constant velocity. Constant velocity will give you acceleration equals to 0 when you have F equals to MA as your A equals to 0, which will give you your force equals to 0. So first, when your acceleration equals to 0, constant velocity. Next, if you applied force but there is no displacement. Example, you push a wall. So there is no displacement. The wall does not move. So this is basically no work done. Force exerted on a building, no work done because of your displacement equals to 0. The wall does not move. Or when you have the third variable, cos theta, so you have your theta equals to 90 degree. This is when your force is perpendicular with your displacement. You want to move this car at this direction, but you applied force perpendicular, so this is also no work done. Example, centripetal force acting on the car moving with a constant speed in a circle. So when a car moves in a circle, this is the displacement, and then this is the force applied, centripetal force. Sign for work W, it can either be a positive or it can be a negative value. What does positive work mean? When you have your work more than 0, so it is a positive, that means that the work is done on the system by external force where energy is transferred to the system. If your work done is less than 0, which will give you a negative work, that is meant by work done by the system where energy is transferred from the system. Okay, negative work done when you have your angle is 90 to 180. So example, this is your displacement and your friction. Okay, example, this is your friction, so 180. Or you have one force in this direction. Okay, work done by the system where your angle between 90 to 180. The first one, work done positive, work done on the system where you have your force between 0 to 90. So your force either F1, F2 or maximum. Your maximum should be less than 90. Then this is the first case. This is the second case. Work positive, work done on the system. Work negative, work done by the system. Work done by variable force. So, besides calculation, you can also calculate your work done based on the area under the graph of F, Newton, against displacement in meter. So, when you have a graph of force against S, the area under the graph, will give you work done. So work done is the integration of F ds. So integration will give you the area under the graph. That's all for lesson today. Lesson 4 will end here. Thank you.